things that you should have learned how to do, or the things you should have learned through those pre-labs and labs and lecture from last week. So that way we can just check in. The idea behind these slides is all of these things you should be like, yep, got it. Yeah, I did that. That's the idea. You do not have to write these down. I will always post the slides on D2L, a PDF version, so you can refer back to them. So I'm going to go over them rather quickly each time. So some of this stuff is general, like you started to get used to the environment and the shortcuts, so Control C, using the up and down arrows to page through your previous commands. Another thing that you learned through writing your first M file is that, remember that code always is reading from top to bottom and left to right. If you define a variable below where you call the variable, the program isn't going to know about that. So there's an order to how your program is read. Another thing that you should have learned, I know I told every single person that I talked to in lab, that every single line of code that you write should be suppressed, and then you should only display the things that were specifically asked for. Suppression means that you have the semicolon at the end of the line. You learned how to define and use variables, and this is something that I actually only saw one person do incorrectly, but I wanted to make sure that you knew that the equal sign is reserved for a definition, so anything on the left-hand side of an equal sign means it's a new variable or it's a variable that's now going to have the value on the right side of the equal sign. And that's what the equal sign means exclusively. It doesn't mean an equality sign, so you can't put some long equation and just tell MATLAB that the right and the left-hand side equal each other. It's only used to define variables. So that means that it has to be in this order, and it can't be in the order that I've crossed out. And then, like I said, all your lines should be suppressed, and then you should only be printing to the screen the things that were specifically asked for. So this is particularly important when you write quizzes. Every line should be suppressed, and the quiz will tell you what to display. You guys all experimented with different ways of displaying, but I've listed up the 3 ways that you can use, the 3 different ways that you can display. They all have different features. Another thing you may or may not have explicitly noticed is that you started to experiment with different data types. So a lot of the variables you used were numbers, like a = 5, but then you also had to use things called character strings or text strings, which are using the single quotes around them, and that's just going to verbatim print whatever text. I actually had to take out a section of this course on data types because of the 2 holidays this semester. So the fall semester learns about data types and this semester doesn't. So I just wanted to add in a little bit about this. The types of numbers that are in MATLAB are floating point numbers, which you can just think of as decimals, or integers. The only reason you would use an integer type number is because it takes up less bits in your computer, so you can store more of them if you're doing a lot of analysis. And the default data type for MATLAB, so if you just define a variable and you don't do anything, is a 64-bit floating point number, which is just the one that takes up the most space to store. And then the last thing that I wanted to make sure that you all saw, I think most of you ended up getting to this, but people did this a variety of ways, but how to display text to the screen. So using these variables that I've defined up here, I have a = 5 and b = apples. If you want to display more than one thing in your display command, the first thing you have to do is you put square brackets around it, and that's what we're going to learn about today, which is an array. And then you separate each individual thing that you want displayed with a comma. The second thing you have to do is everything inside that array has to be the same data type. So since A is a number and B is a text string, you have to convert the number into a text string in order to combine them together in the same array. So we use this a lot. In case you used fprintf or a different way of displaying, I just wanted to make sure that you saw this way as well. Okay, and then I wanted to just summarize some things that I saw. A lot of people had these same things happen to them, so I wanted to summarize them so that you can kind of start getting a list going of common bugs that you'll encounter so that you can start learning to debug on your own. So the first thing that happened I probably helped 10 people with this problem, which is something weird was happening where they thought that they were using something completely correct and there was some odd error message that didn't allow you to use a function that you normally could use. So for example, someone was trying to use the disp function and it wouldn't let them. It had some error that was not understandable. And when you looked in their workspace, it's because they overwrote the disp function with a number. So they used it as a variable, disp equals 1, and then they could no longer use the function. And I told you that last time that it does allow you to overwrite intrinsic functions. So a lot of times things like that can happen and you can't tell that they're happening. And the way to always check without doing a lot of investigation is to clear out your workspace or type clear all at the top of your file, and that usually fixes it. The second error that I saw a lot and helped with people is just typos. So if you ever see something undefined function or variable and then it lists that variable, it usually just means that you spelled it wrong or you haven't defined it yet. So this was supposed to say Fred, and when I typed it later in the file, I just used an I instead of an E, so it didn't know what that function is. And then the last thing that happens, especially when you're using input prompts, is that your code can get stuck asking for responses, and you no longer have those double arrows anymore. And you can't run your code unless you see those double arrows. If you're still in the middle of an input prompt, it's like still back 10 steps behind you. So you have to press Control-C, Control-C, Control-C until you get the arrows back to start running your code again. So that's my 2 review slides and then some tips and tricks that I hope you learned, or at least I could summarize for you from topic 1. What we're going to be doing, talking about arrays. And let me just switch over so I can record what I'm writing up here. I have a couple examples we're going to do today. Not examples, a couple kinesthetic activities. They're my favorite activities to do in lecture, but they're really hard to come up with. But they're ways of getting people up out of their seat or seeing movement. I've come up with several, and I will try to do them whenever I can. I actually had all of your TAs take a learning style test because I was trying to explain to them about different learning styles, so when they helped you, they could think about that. And 2 of them were very strong kinesthetic learners. Like, they were very, very high, and I actually think most technical or engineering students are. So I try to incorporate it. One way to learn if you're a kinesthetic learner is to write while you're listening. That's the number 1 thing. So that's why I like to write notes on the board so you can follow along. Okay. So up until this point, everything that you've done in the code that you've written has been variables holding a single value, just one number. And so most of what we do in engineering and science is look at large data sets. I guess I'll start by just defining what an array is in the most general sense. It's just an organized collection of single numbers. And as I told you last time, MATLAB stands for Matrix Laboratory, and its strength is that it's able to deal with matrices or arrays in a very efficient way. So what we're going to do today is talk about the different types of arrays and then all the different things that you need to be able to do with them in MATLAB. A lot of what the pre-lab does is has you practice some of this as well in the MATLAB program. So I'm going to start with a 1D array. And so this is a normal vector quantity. This could be something like a normal vector quantity that you've seen before in your physics and mechanics classes. So let's just do a velocity vector field. So the three components of velocity, x, y, and z, for example, is a type of array. It's a 1D array with three dimensions to it. However, an array can also be in the other direction, in the vertical direction as well. So I'm going to show you in MATLAB how to store numbers in both a row and a column. And so these are the ones that you have used countless times, and they only have one dimension to them. So when you need to access any part of the array, you only need to include one index because there's only one direction to the arrangement of the indices. So if any of you have taken matrix algebra or linear algebra, you've probably dealt with a lot of 2D arrays, which are called matrices. So those types of arrays have two dimensions. I'm just going to put the identity matrix up because I would imagine that's something you have all seen. And again, this is one of the strengths of MATLAB, and I'll explain this when I show it to you, but is that it's able to handle all sizes of arrays, but specifically matrix style arrays. A lot of the commands you'll see were defaulted for this type. And then you can go up from there.
So two-dimensional doesn't necessarily mean only one row, one column, or two row, one row, one column. It could mean like, as long as the rows and columns are both divisible by 2.
No, it doesn't need to be that. It just needs to have rows and columns. Yeah. So, I have on here one more dimension, a three-dimensional array that I've drawn, because that's the only next one that I can draw for you. But you can go up to 40, 5D, 60. There's no limit. You can have as many dimensions as you want in storage. It's just the way that they're indexed. So once you get kind of beyond a three-dimensional one, it's kind of hard to visualize how it's stored. So a lot of people don't use that. They would rather just use multiple variable names separately and not combining them all in the same name. Okay, so what I'm going to show you is, I'm just going to summarize everything I'm going to show you, and then I'm going to stick in MATLAB from here. So you'll see these same things used in your pre-lab so you can have some connection. So we're going to learn how to define, manipulate, access arrays. So those are all three things that I'm going to show you how to do. I'm going to show you how to define one, how to do something to one of them, like multiply it by something, how to access individual elements of an array. And then I'm also going to show you a little bit on memory allocation. And cell arrays and strings. So you should see me hit all of those points when I'm going through it in MATLAB. And I'm going to also simultaneously show you with you as some data points as well. So I'm going to switch over now. I'll leave this up if you're still finishing writing. So, dang, just want A to be in the front row. All right. So, volunteer accepted. You are one. So I'm going to use the front row as kind of a visual example of an array. Do I need to make this font even bigger than it is? Okay. So what I've done is I have given the front row each a data point that I have up here in this array. So I did it from your perspective looking this way. So this reads from left to right. So the first data point is 7, and then you're the first data point, right? 7. And then that's the last data point at the end, 15. Did that work? That's what you are? Okay. Okay. So the first thing I wanted to show you is how to define an array. So I have the command right here, and there's a couple things. So I already showed you this with that text string conversion thing for displays, but are you guys sure that's big enough? You can see that. Okay. I've opened the square bracket, filled the array with the numbers that are going to fill the array, and then I've closed the square bracket. So this is the one way to define an array. However, all of these, and I've already entered this, so you see that it works fine. However, these commas are optional. So you can also just use spaces as well to define arrays, which I typically do because why would you want to type in a comma if you didn't have to? Both of them do the same thing. You have to put the square brackets there, though, to indicate that it's an array. So as we saw last time, functions like disp, do we use any other functions like cosine, sine? All those functions use parentheses around them. And then arrays are exclusively reserved for square brackets, definitions of arrays. So that's how you define a 1D array. So now I'm going to show you how you can manipulate an array, for example. So actually, before I do that, I'm going to show you how to access an array. I think it'll make the demonstration easier. So which index should we access of this array? Can you actually tell me the location? So 1 through 8. 1, 2, 3, 4, 5, 6, 7, 8. 7. Okay, can index 7 please stand? Okay, so this is the data point number 7. His card says that he's index 7 and your value is what? 19. So if I want to index just the 7th element of this array, I can just type in the index number inside whatever variable name I use, which is data, and I can get his number. So now if I want to do something to this array, I want to manipulate it, I want to double it, let's say. So if I doubled your array, what would you be? $38. So 2 times that value is 38. So there I just accessed one element, I multiplied it by 2. So you can sit down now. So that's one way to do it. Another way to access is to access a collection. So I'm going to give 7 a break, and I'm just going to access 2 through 4. So if you're 2 through 4, can you stand up? So these are just elements 2 through 4. So I'm first going to just do 2 through 4. And all it's going to give me is the values for 2 through 4. So is it 324? Is that all right? Now if I want to manipulate just those 3, then I can do 2 times and double each of those elements separately. You guys can sit down now. Is this helping? Visualizing? Something to do, right? the thing that's interesting about MATLAB is when we did just element 7, it took MATLAB the exact amount of time as it did for MATLAB to do the calculation on 3. And I can repeat it and do it to the entire array and double all of them, and that is also the same amount of time. So that's the strength of MATLAB. It can do calculations simultaneously on an entire array, and it does it all at the same time by the way that the data structure is designed. So to really get the benefit of using MATLAB, you want to avoid doing element by element multiplication or anything and doing them individually and trying to do them all at once like I just showed. Okay, so a few other things. If I wanted to change and instead of putting it in a row like I did, I could change the original definition here and I could put it in a column. So I'm going back to definitions of arrays and I'm now showing you how to do a column definition. So here, instead of putting spaces or commas, you put a semicolon and that will make it a column of data. And accessing that column of data, if I want to go to 7 again, is going to work exactly the same. So 2 times the 7th element, it's still accessed in the same order because there's only one dimension. Do you guys have any questions so far? Okay. Alternatively, you can create a column vector. I'm going to go back to the row notation. And if I want to still be able to just define it using those spaces that are convenient, but I just want it to be a column, the transpose feature is to just put a single quote at the end of the array, and that transposes it to a column as well. Okay, so I've showed you how to do row vector, column vector definitions. Now there's one other thing that's really convenient for defining arrays. So a lot of times the arrays that we need to define are a pattern of some sort that's easy to fit some analytic function to, or analytic pattern to. So for example, let's say that I wanted to create an X vector that ranged from 0 to 100, and I wanted it to just do every one. That's where you're going to use something called the colon operator, and I'm going to talk about this a lot, where you put in where you want it to start, where you want it to end, and you put a colon in between, and that will just give you automatically 0 to 10 with a step size of 1. So that saves you a lot of time if your array has a natural pattern to it. There's an alternate option that you can add in between the two. So you can do the starting point colon, step size colon, and then the ending point. So instead of doing every 1, I could change it and do every 2, and it will skip every 2. And that can be any combination of anything, starting point, ending point, and step size. Okay, and the one thing about the colon operator that you will see is that it's the single way that you can define an array where the brackets are optional. So if you ever see this definition somewhere, for example, in some of the loops that we do, you'll just notice that those square brackets are missing. And that's because if you define with a colon operator, those are optional. Those are optional in the definition. Okay, so let's talk a little bit about a few special functions that are convenient for defining variables. So there's 2 that I want you to know about. One is a function called zeros, and it creates an array of whatever size you would like, and it fills it with zeros. So I'll explain why we need this later, but This is basically what we're going to use to pre-allocate our arrays, which speeds up MATLAB's functionality a lot. So here I've said that I want 1 row and 10 columns. That's the size that I want. And then I want that array to have all zeros. There's another function called ones that does the same thing but with ones. So depending on whether you're multiplying or adding in the code that you're writing, sometimes you'll want zeros and sometimes you'll want ones to give your array a starting point. Okay, so I have a few more things to show you with manipulating arrays. So, do I still have my data here? Okay, so I'm going to go back and just use a row again because it makes it a little bit easier to see what's happening. But as I showed you, if you do anything to this array with scalar quantities, so I showed you how to multiply this by a scalar, you can do the same thing by adding a scalar to it. Any of those scalar multiplication, division, or addition or subtraction can be done exactly as you would expect. You just multiply or add that number to it, and it will do it to each element. So I'm actually going to define 2 different arrays. One is going to be the original data that I gave you, and then the other one is going to be that array with 3 added to each element. So now I have 2 different variables. One is the original and one is slightly adjusted. So a lot of what we do is we store our data in arrays, and then we need the data to be multiplied by each other element by element. So for example, I have this data and I have this data, and I want to multiply this element by this element by this element, etc. So element by element multiplication is what it's called. So if you just multiply using a multiplication symbol, you'll always get this error. This is a very common error that you get, which is matrix dimensions don't agree. You actually get that error for a lot of other things that are further from exactly what we're seeing here. So this is what I was saying, that MATLAB is set up to do matrix algebra, or matrix multiplication. So I'm going to show you here what the default multiplication is in MATLAB. Just going to have to do it down here. I'm running out of space. So this is what happens if you just use the multiplication sign. This is what MATLAB is trying to do with it. So if any of you have taken linear algebra, you know that a lot of times you set up matrices that are 3 by 3 and 3 by 1 to show a system of linear equations. So let's say I have, just going to fill this with numbers. If you use multiplication like this, what it's doing is matrix multiplication. So it's going to do this row times this column. So it'll be 1 times 1 plus 2 times 0 plus 3 times 1, which is 4, right? And it's going to do the next row times this column. 4 times 1 plus 5 times 0 plus 6 times 1. So that's 10. And then the next one is going to be 7 times 1 plus 8 times 0 plus 9 times 1, which is going to be 16. So that's the default of what it's trying to do. So unless the dimensions agree, which means that if you've ever used this before, it means that these 2 dimensions have to be the same in order to do matrix multiplication. It's going to give you an error. But in this class, we're never doing this. We don't do matrix linear algebra or anything. So we're never trying to do this. So you should basically never be multiplying two arrays with a single multiplication sign. Does that make sense what this is trying to do? Okay, so let me show you by defining these two really quick. And then so if I just do A times B, you'll get the same thing that I just wrote down for you, okay? So what we're typically trying to do is do what's called element by element multiplication. So in order to do that, you're going to need to use a dot before the multiplication sign. And what that does is it requires the two matrices to be the two arrays to be the exact same dimensions, and it's going to take each location and multiply it by the equivalent location in the other one if you're doing multiplication. And if I created another array, or if I just erase, I'm just going to erase one of the elements of data 1. So now data 1 is only 7 long and data is 8 long. This is a very common thing that happens as well, that the two become different sizes for whatever reason. That will also give you the same error that they don't agree, even though you're using the dot. I don't know what that was, but we'll put that. Okay. So that's with the dot. And so the dot needs to be used for multiplication, division, and powers. Anytime we do any of those three operations, you need the dot. You do not need the dot for plus or minus. If you're adding or subtracting matrices from each other, they just need to be the same size. The dot's not necessary. But it's necessary for multiplication, division, and powers. So if you wanted to square every element of data, for example, it's the same thing as multiplying data by itself, right? So it sees it as the same thing. So you would need the dot there too. So the most brainless thing you can do is just always put a dot before any of these things. But if you ever are doing scalar multiplication, division, or powers, actually that doesn't make sense for powers, but then you actually don't need the dot. But that's the functionality of the dot. Does anyone have any questions about the element by element manipulations? Okay, so another thing I wanted to show you about manipulating arrays is all of the functions can operate on arrays. So I can take the cosine of an entire array. I can take the sine of an entire array. And it's the same thing that I just said. It's way more efficient than doing them element by element because it does it all at the same time. Okay, there's two functions that I want to make sure that you have seen. The first function that we use all the time is the length function, which will tell you how many elements are in an array. We typically use this when we're reading in data. The first thing you want to do when you read in the data is see the size of the data. So you either take the length if you know it's a 1D array, because then you just want to see how many elements it has, or if you don't know anything about the data, then you can just take the size of the array, which will tell you all the dimensions of that data. Okay, so I want to go into accessing now, but go into accessing 2D arrays. So I wanted to get a volunteer from this front section of the room. I just need one person who's somewhere in the middle in a random seat. You're not a great option. You're a good option. You're raising your hand. Okay. How many rows do we have? I really appreciate you volunteering. You're just in a weird spot. How many rows do we have before that big table starts? 1, 2, 3, 4, 5, 6, 7 rows? Okay. And I'm going to assume that there is what did I just say? 7 rows? And I'm going to assume that there's 10 columns. So here you can see the 7 rows are showing up, right? And then there's 10 people across each column. So we're going to take this and look at it the same way you're looking at it, not the way that I'm looking at it. And we're going to try to see how we access, what's your name? Jake. So this is now a 2D array, right? It's very possible that there's not 10 people in the row, but let's just say that we think that he is in the 9th place of his row, okay? So the best way to learn is to just try. So you're in the 6th row and the 8th or the 9th location. What? Oh, I used class, sorry. I used class, not data. So what I'm going to do is I'm going to pick out that location, so 6th row, 9th spot, and we're expecting that if this is right, that something over here should turn to 1, because I'm going to overwrite the 0 with a 1. So, okay, I didn't mean to get it right. I thought I would have to try a couple times, but I think I was right. So it is exactly organized the way I just said. So the row is the first element, and then the column number is the second element. But you can actually do it 2 ways. So there's about 70 elements. So if you have a 2D array, you can also use a single number. So he's probably like 57, something like that. No, not even close. But you can also use a single number, and I think the single numbers are ordered in this direction here. Honestly, I never remember. I always just do this every time to remember which one is which. But you can access using a single number or like a coordinate. And the coordinate is easier because it's the row versus the column. The other thing that's nice to get used to is using the colon operator for accessing. So let's just say I want to mark off the whole first row. That means I'm going to pick out the first row and I'm going to choose all of the columns in the first row. That's what the colon operator does. So if I do that, you'll see that my entire first row changes to 1s because I use that colon operator. You can use it for the column in reverse too. So if I want to change the first column, I can just switch it and it will reverse it. So that's how you access 2D arrays. You can either use the double notation, the single notation, or the colon operator. And then as I just showed you, you can call out and replace specific values in an array by just overwriting it. Okay, so if you're going to build, the next thing I'm going to talk about is memory allocation. So if you're going to build an array in parts, so let's say that I'm going to start building this array, and I start with a row of 5, and then I decide that I want to add rows underneath it 1 by 1. So I want to go and add a second row of 1 through 5, and then I want to go and add a third row of 1 through 5. What MATLAB is actually going to do, whether you add a row or a single element, is every single time you add on to that array, it's going to create a whole new spot in your memory for that array. So if you're doing huge calculations, it will take way longer if you do it this way, where you add on step by step to an array. So I can show you another example where I'm just adding on 1 by 1. So I created array 1 and I put 1 in it. And now I'm going to add another element to it. And now I've decided I want to do another element to it. And I'm just piecing it together. There is a memory, I've already created 3 spots in memory for those 3 things that I just did. So whenever you create an array where you're adding onto it, if possible, you want to create the array first and fill it with zeros, and then go ahead and fill in each one by one as needed. And that way it's not creating new memory for each time you replace that value. It's already set aside memory for those spots, and it will just insert the data in. I'm going to come back to this when we're actually doing stuff with loops, and I'm going to show you how big of a difference it makes. But people who are writing codes like me in graduate school, it can make like 10 times the amount of time of runtime. So it can change it from taking 10 minutes to run to taking 100 minutes to run. So it makes a huge difference. The last thing I wanted to show you today is something called a cell array, or just in general show you how to store strings in arrays. So you did a little bit of this last time, where you might have created some variables to hold some character strings in your code. So the first thing I want to point out is that if you use a regular array like I have here, it's going to access each letter as an element. So I just called out text of 1, and it just gave me the S of my name. This is oftentimes very inconvenient if you want to create an array of many names, for example, because then you would have to have the same amount of characters reserved for each name or each description that we're using, and we do a lot of stuff with text in this class. So a better option for a lot of what we're going to be doing is something called a cell array. A cell array creates each word as an element. So if I want to only get the first name, so I access the first element, it will give me the entire name. And the only difference, as you'll notice, is that instead of square brackets here, it uses curly brackets. So square brackets are reserved for regular arrays. Curly brackets are reserved for what's called cell arrays. Another advantage of cell arrays is it lets you mix strings and numbers all in the same array. So it can store any kind of data types together, which we're going to do in one of our assignments. However, the display of characters or cell arrays is very difficult, so you kind of want to avoid using them. And the last thing I wanted to show you with this is that if you use curly brackets here instead of parentheses to access elements of a cell array, it actually converts the data type back to the original data type you were trying to use. So now this is going to be treated just like a string, where this is treated like a cell element, which you can experiment with a little bit in your pre-lab. So a lot of times you have to use this if you're trying to use it as a number or use it as a string later. You guys have any questions about that? I actually don't know. I can try. Yeah, they're still optional. Any other questions? Okay, thank you. I think you can, yeah. I think you can. Nope. Yeah, I'll take that.